In this video, which is basically the main topic of 11.2, we're going to be talking about how to shift certain functions, the graphs of the functions specifically. So this is going to be the third part, obviously. So this is going to be the final part as well. So I want to go ahead and go straight into the main point of this, and that is point number 3. Remember that the first video was section 1, and the next video was 2, but I forgot to label it. But the third main point about this is that we can make modifications of these basic functions. Remember the basic functions from the previous video, the graphs that you should know. We can make modifications of those basic functions to make new functions with new graphs. So we can just take the previous graphs, like remember that we had x squared was this. We can take the basic equation f of x equals x squared, and we can make modifications to it. And the modifications that we're going to talk about today, like any parabola that opens up or down, is actually a modification of this. Every single parabola that opens up or down can be somehow related back to this equation. I know that might sound strange, but that's actually true. So today we're going to be talking about the shifting modification. So today we're going to be talking about the shifting, not the shifting. Today we're going Today we're going to be talking about shifting a graph. So to shift a function up or down, any function, this applies to absolutely anything. So to shift a function up or down, add a number on the end. Like, for example, f of x plus 5 looks exactly like f of x, except it's moved up 5 units. If it's negative, like if it's f of x minus 5, then it'd be moved down 5 units. I'll go ahead and write that down. So f of x minus 5 is exactly like f of x, but moved down 5 units. So if it's plus, it moves up. If it's minus, it moves down. So let's go ahead and erase that. So let's take, for example, f of x equals x squared plus 1. So f of x equals x squared plus 1. So let's take a look at the regular f of x. So this is a computer-generated graph of f of x. This is just a regular f of x. Let's go ahead and shrink that down so you can see the actual function. But we just added 1 to it, so we want to move it up. Let's see how well this will work out. Okay, so we just took f of x and we added 1 to it. So let's start. No, let's not start that over. So when we added 1 to it, it moved the entire thing up 1. So what about, on the other hand, let's take f of x equals x squared minus 2. So instead of plus 1, we're adding 2. So let's go ahead and let's get back that graph. So here's the original f of x equals x squared again. Now let's move it down 2. So we're going to be doing x squared minus 2. So it's going to be moved down 2. So now the vertex is at negative 2. So those are some examples of what the plus 2 and minus 2 will do. So let's go ahead and go on to an example of moving a function left to right. So to shift a function left or right, replace x with x minus c. So f of x minus 3, for example, looks exactly like f of x. So f of x minus 3 looks exactly like f of x, except that it's moved 3 units to the right. Now I know it might sound strange that it's moved 3 units to the right, because you'd think that, well, it's minus 3, it should be moving in the positive, it should be moving in the negative direction. The reason why that is because, well, it's kind of hard to explain, but I see no harm in trying at least. So if this is x squared, then if we have f of x minus 3, then we're going to be saying, okay, 3 is now our 0, because x minus 3, so you remember where we had, okay, let me compare these two. So x squared means that when you have x is 0, then y is going to be 0. But for this, we're moving it to the right because y is going to be 0 when x is equal to positive 3. See, 3 minus 3 will give you 0. That didn't quite come out exactly how I meant for it to. But basically, probably, at this point, you'd be better off understanding not so much exactly how it works, but just that f of x minus 3 moves to the right, not to the left. It's counterintuitive at first, but that is the way it usually works. Not usually works, that's the way it does work. So, if you want to move to the left, then add a number instead of subtract. So if you want to move it to the left 3, you do x plus 3, and that'd move it to the left. So for example, let's do f of x equals x minus 1 quantity squared. So this is f of x minus 3 because we've taken, see up here, we took the entire thing and subtracted 2 from it at the end. Over here though, we're replacing x with x minus 1. This is going to move the graph to the right by 1 unit. So let's go back to our x squared and let's move it to the right. So we're going to switch from, let me scroll down some. So our example is x minus 1 quantity squared. So let's move it 1 unit to the right. So now we've done that. We've taken x squared and we've moved it to the right. So now let's go ahead and let's change this to, let's make this always on top so I don't have to deal with that. Let's, instead of moving it to the right like we did here, let's move it to the left. So let's add 2 to it. So, oops, not 23. So x plus 2 quantity squared. And let's reset this back to x squared. So x plus 2 quantity squared. Let's go ahead and figure that out. This is x squared, so x plus 2 moves it to the left 2 units. And my computers are struggling to finish it. Okay. So now we've moved it to the left 2 units. Now you can do both of these at once. You can shift left to right, and you can shift up or down. So, let's write that in a more general sense, so you can do both at once. In general, f of x minus c, plus k, I've got the plus k, moves the graph f of x to the right c units and up k units. Oh, new line. Okay, so f of x minus c plus k. So we have some, let's write that more generic, some graph. I don't care what it is. Let's make it this funky thing. That's going to be some cubic something. So if we, I shouldn't have put it so far in right in the middle. Let's go ahead and put that back to the left. So if we want to move this to the right, so if this is f of x, if we want to move this to the right some, we'd add something like f of x, replace all of the x's with x minus 3. So we replaced all the x's with x minus 3, and you'd get this graph. That doesn't quite match, but it's kind of sort of close. But let's say we wanted to move it up. So we'd have f of x plus 3. This would move it up. So we'd have, so now I'd only cross at 1 point instead of 3. Alright. Let's go to a similar example. Let's go back to the parabola, where we combine. See, this only does them individually. So let's do an example where we have f of x minus 3 plus 3. This is where we're going to be moving to the right and also moving up, so it's going to look something like this. Sort of. This will probably come down lower, I think. But let's go ahead and do this on the grapher. That way we can see it more clearly. So, for example, f of x equals x plus 3 squared minus 2. Okay, so what we have here is a function. We know it's a variation of a parabola. It's a parabola that's been moved to the left 3 spaces and down 2 spaces. But you might be thinking, we've already dealt with parabolas. They don't look like that. Actually, this is just a different form. If we multiply all this out and then simplify it, we will get a parabola again. So let's go ahead and graph this. So let's get back our, so this is the one we just had, so let's get back the original. Let's reset it. So here's our x squared. Now let's scroll down a little bit. So first thing we want to do is move it to the left 3 spaces. So let's move it to the left 3 spaces, and my program just crashed. Let's restart that. Okay. Here's the new graph. So we want to move it to the left 3 spaces. it doesn't die this time. 3 units, I should say, not 3 spaces. Okay, so that's good. And then we want to move it, sorry, and then we want to move it down 2 units. So it's moved to the left 3 units and down 2 units. So we know now that we have a parabola that opens up, has the vertex at -3, -2, but wait a minute, this doesn't look at all like a parabola that we've usually worked out with. Well, let's go ahead and multiply all this out and see what happens. So we have x plus 3, and I'm going to go ahead and do this with the cursor, with the mouse. So we have x plus 3 quantity squared is, let's go ahead and do it this way. So we have x squared plus 6x plus 9 minus 2. I just multiplied this x minus 3 quantity squared out. So we have x squared plus 6x plus 7. Now, this should look familiar. Aside from the fact that it's sort of diagonal, it is a parabola. And now we can find out where the vertex is going to be using the traditional rules, -b over 2a. I'll just do that much, but I won't actually go further than that. -b will be -6 over 2a. We'll still have -3, but -3 is what we said would be the x value of the vertex based on this, because we knew we moved it to the left 3 spaces. Okay, that last part, connecting this to this, is not really necessary, but I wanted to go ahead and show you how to move functions, move graphs using these concepts. So I will see you in 11.3.